Regulatory bodies. The entire frequency spectrum is composed of all possible frequencies from very low up to the cosmic rays. The part of the spectrum that is usable for radio communication, the radio frequency or RF portion, range from about 3 kHz to 300 GHz, as I mentioned before. Frequencies within the RF spectrum are available because they exist everywhere, but it would not be wise to use any frequency at will. For example, suppose someone decide to set up a radio transmitter to broadcast a signal on 123.45 MHz. Unless other people know about the transmitter's frequency and have radio receivers that can tune to that frequency, no one will be able to receive the signal. Even further, a frequency might be used by one entity for a specific purpose, while another entity might try to use the same frequency for a different purpose. To keep the RF spectrum organized and open for fair use, regulatory bodies were formed. In this video, we will learn about some of these regulatory bodies. First, about the ITUR. A telecommunication regulatory body regulates or decides which part of the RF spectrum can be used for a particular purpose, in addition to how it can be used. A country might have its own regulatory bodies that controls RF spectrum use within its borders, but RF signals can be more far-reaching than that. For example, one purpose for shortwave radio station is to broadcast from one country around the earth to reach other countries. In a similar manner, one radio manufacturer might sell its equipment internationally, where a transmitter or receiver might be used in any global location. To provide a hierarchy to manage the RF spectrum globally, the United Nations set up the International Telecommunication Union Radio Communication Sector, or ITUR, http://www.itu.inet, and the ITUR maintains spectrum and frequency assignment in 3 distinct regions. As you can see here, we have Region 1, Region 2, and Region 3. Region 1 include Europe, Africa, and Northern Asia. Region 2, North and South America, and Region 3, Southern Asia and Australia. While the ITUR strive to make the RF spectrum usable by all countries, it also tries to make sure that the RF signals from one country do not interfere with the signals of another country. It also attempts to determine the expected usage of each segment of the spectrum. The ITUR even keeps tracks of geostationary satellite orbits and frequencies so that signals for one country's satellite do not harmfully interfere with those of another country. Most bands in the RF spectrum are tightly regulated, requiring you to apply for a license from a regulatory body before using a specific frequency. The regulatory bodies typically determine the allowed type of emission and set limits on things like the emission source and power. License bands might seem restrictive for a good reason. Harmful or disruptive interference is kept to a minimum because frequencies are reserved for approved transmitters, purposes and locations. To use a frequency in a license band, someone has to submit an application to a regulatory body that governs frequency use in a given country, wait for approval, and then abide by any restrictions that are imposed. In contrast, the ITUR allocated the following 2 frequency range specifically for industrial, scientific, and medical ISM applications. Although there are other ISM bands we have other ISM bands too, there are mainly 2 that apply to wireless LANs. 2.400, as you can see here, to 2.500 GHz, and 5.725 to 5.825 GHz. The purposes for these bands are broad.